Hi, welcome to week 3, the last 2 lessons for quadratics. We are going to be doing what we're going to call 12.5 and 12.6 this week. You will have notes and worksheets that you will need to do and send me pictures of. Make sure you show me the work. And then in this week, you will have a goformative.com homework check as well for 12.5 and 12.6. It'll be a pretty light week with those. The following week, we start properties of exponents and then factoring and kind of conclude our year with that theme all the way through. Remember, everything will be due by midnight on Friday. So this one, it is going to be the 17th. So 17th at midnight. Make sure you send me your pictures of the 12.5 notes, worksheet, 12.6 notes, and 12.6 worksheet. I won't do this kind of recap for 12.6 when I film that one. So here we go. It says, problem 1, the vertex of a parabola in symmetry. The vertex of a parabola is the point at which the parabola goes from increasing to decreasing or vice versa. And we've talked about that before. We kind of call the vertex our turning point. So I like writing that right up here. And I'm going to say it's my turning point, right? And at that on the x-axis, that turning point along the x-axis, it's not the parabola is neither increasing nor decreasing because it is literally turning, okay, right there. So it also says the absolute maximum or absolute minimum is always located at the vertex, and we know that. And the axis of symmetry of a parabola is the vertical line that passes through the vertex and divides the parabola into two mirror images. We commonly refer to that as AOS. And that abbreviation we will use for axis of symmetry, right? And then we know that kind of what that does is that kind of makes my parabola, when I draw my parabola, my axis of symmetry is going to be the vertical line that goes right through that parabola and cuts it in half. It allows it to fold right on top of each other. So if you think about my two hands being the either side of the parabola, and if I folded that parabola onto itself, every point would be the same, exactly the same. All right. It also says that, hang on. Because the axis of symmetry always divides the parabola into two mirror images, you can say that a parabola is symmetric. We know that already. We've talked about that. So how would you write the equation for axis of symmetry? In other words, how do you write the equation for a vertical line? Well, remember, you know that the equation for a vertical line is x equals a number, right? And so therefore, how do we write it for the axis of symmetry? Well, our axis of symmetry is going to be x equals the x value of vertex. All right, so that's what we're going to be. All right, keep going. It says, using the idea of symmetry, use the given information to answer each question. Do not use a graphing calculator. Show your work. All right, so it says, determine the axis of symmetry of each parabola. The zeros of the parabola are at 1 and 5, 0. So if I'm thinking about that in my head, and I'm thinking about a parabola right here, just like this, but I know it goes through, a graph that looks like this. So I know my zeros are 1 and 5. And since I know this is symmetric, I know that those are even distance away from the axis of symmetry. Like 1 to the axis of symmetry is the same distance away as the axis of symmetry to 5, okay? And the best way to do that is we can use midpoint, right? We can find the midpoint of the distance between 1 and 5. Okay, and let me scoot that so you can see me more clearly, between 1 and 5. So I can take 1 plus 5 and divide it by 2. So that's 6 divided by 2, or 3. So my axis of symmetry is x equals 3. And I know this because I can use midpoint to find the average between 1 and 5, okay? I can use midpoint to find the average between 1 and 5. It's a midpoint formula, right? I'm just using it for the x, though. I'm not using it for the x and y. I'm just simply using it for the x. All right. Number B, the zeros of the parabola are at negative 3.5 and 4.1. So once again, negative 3.5 plus 4.1 divided by 2 ends up being 0.6 divided by 2, or simply 0.3. So my axis of symmetry is x equals 0.3. Okay? Two symmetric points on the parabola are negative 7, 2 and 0, 2. Well, this time they're not zeros, but they are symmetric points. And remember, as long as I pick the point directly across from the other point, they are still the same idea as the zeros. It doesn't matter where on the parabola I find my two symmetric points, as long as I use symmetric points, meaning they're across from each other, right? So the same idea here. Take this and have negative 7 plus 0 divided by 2. So that's a negative 7 divided by 2, or simply negative 3.5. So I know my axis of symmetry, oh, no, go down. Axis of symmetry is x equals negative 3.5. Now you notice I'm writing it x equals every single time. So I know that that is my equation for the axis of symmetry is x equals whatever the value it is. In this case, negative 3.5. And then last it says describe how to determine the axis of symmetry given the zeros or two symmetric points of a parabola. Well, we want to find the average. We want to find the midpoint. Written as x equals whatever the value is, right? Okay, turn the page. Now it says, determine algebraically the location of vertex of each parabola. Okay, well that's easy. Well, I think, isn't it? So determine algebraically, so we're going to solve a problem here, okay? Algebraically means we're going to plug something in and solve, okay? And it says the vertex of each parabola. So we want the vertex. So we definitely want the x, y value. Not just the axis of symmetry, but the x, y value, okay? So as I do this, I'm going to bring this down just a little bit so we can see the top. So I'm going to read the problem. And the problem says the function f of x equals x squared plus 4x plus 3 has the axis of symmetry x equals negative 2. Whoa, we already know something. We know our axis of symmetry is x equals negative 2. So I already know negative 2 for my vertex. I know that it's given to me, okay? So as we do this, we want to find the y, right? We're solving for y. We're solving for the y value of our vertex. Well, whenever I have an x and I want to know its y, all I have to do is plug it in. Plug it into the equation and solve. So I know that if I plug in a negative 2 in for x, I can solve for the y value. Remember, f of negative 2, what that basically saying is that I'm plugging a negative 2 in for x and I'm solving for y. That's what this function notation is. So when I see this, I know that f of negative 2 is equal to negative 2 squared is 4 plus negative 8 plus 3. Well, that looks like negative 1 to me when I add it all up. 4 plus negative 8 is negative 4 plus 3, negative 1. So I know that my y value here is going to be, y is going to be equal to negative 1. I'm really going to write that as f of negative 2 equals negative 1. Okay, so I know that this is a negative 1. Okay, so the bottom line is, if I know the axis of symmetry, then plug in and solve for y value of vertex. Okay? All right. So let's do the next one. The equation of the parabola is y equals x squared minus 4, and the zeros are at negative 2, 0, and 2, 0. Well, this time I didn't get the axis of symmetry, but we're doing exactly what we did on the first page, and that is I need to find my axis of symmetry. So my axis of symmetry here, it's going to be found by taking negative 2 plus 2 and divided by 2. Well, that's 0 divided by 2, so that's 0. So I know that my axis of symmetry is x equals 0. So now I get to plug in and solve. So this is y equals 0 squared minus 4. So y equals negative 4. Because 0 squared is 0 minus 4. So it's simply y equals negative 4. So I know my vertex here is 0, negative 4. All right, let's look at C. The function f of x equals x squared plus 6x minus 5. And it has two symmetric points at negative 1, negative 10, and negative 5, negative 10. Doing the same idea we just did in B. Okay, find the axis of symmetry. So my axis of symmetry is going to find the average of the 2 points. So negative 1 plus negative 5 divided by 2. So negative 6 divided by 2, or negative 3. So I know my axis of symmetry is negative 3. So I can plug in f of negative 3 into the equation. So negative 3 squared. And I'm going to put that inside parentheses because I want that negative to go with it, right? I want it to be a negative times a negative. Remember, if I leave it no parentheses and I just put in negative 3 squared, it may give me a negative number in my calculator. We'll talk about that in the next unit, okay? So make sure I put that in parentheses, plus 6 times negative 3 minus 5. So f of negative 3, that's 9 minus 18 minus 5. So f of negative 3 is going to be negative 14 when I add that up. 18 and 5 is 23. Subtract 9 from that is 14. But the 18 and 5 are negative, so negative 14. All right, so I know my vertex is at negative 3, negative 14. And it says, describe how to determine the vertex of a parabola given the equation, the axis of symmetry. Well, I'm going to change colors, determine the axis of symmetry unless given to you, right? And I don't want to skip that step in this. I know the question says, given the equation and the axis of symmetry, but a lot of times I don't want you to forget that sometimes you've got to find the axis of symmetry first. So determine the axis of symmetry given to you. Then plug AOS into function, which is my equation, right? And solve for y. And there we go. All right, last little bit right here, number 4. Now this might be a little bit hard for some of you to grasp right here at the beginning, so I'm going to try to go a little slow. Remember, you can always pause and go back and do all that. And this time it says determine another point on each parabola. The axis of symmetry is x equals 2, a point on the parabola is 0, 5. Okay, so axis of symmetry is x equals 2, and a point on the graph, point on the parabola is 0, 5. Okay, and we don't know exactly what point that is, right? But we just know it's a point on the graph. So what I want to do is this right here, and I'm going to write it first, and then I'm going to show you. I'm going to subtract the x value of point given from axis of symmetry. Okay, that's step 1. So AOS minus the x value of the point. AOS minus the x value of the point. Now I know it says subtract the x value of the point given from AOS. Remember, from AOS means AOS minus this. Then take that sum and add it to the AOS. Okay, those are my 2 steps written in English. Now, a lot of times this is easier to see by doing it. Okay, so I'm going to do step 1 right here in red, right below. And I've labeled it 1. So subtract the x value of point given from AOS. My AOS is 2. I'm going to subtract the x value of the point from it, 0. That is 2. Very easy. Okay, now step 2. I'll do it in blue so you can see it. Take that sum, 2, and add it to the AOS. 2 plus 2 is 4, right? Yes. So where is that point on the graph? Well, that point on the graph is going to be at 4, 5. Now you're going to go, whoa, whoa, whoa. How did you get 5 for the y value? Remember down here, and I'm going to highlight it. I'm going to highlight it in yellow. Remember, the other point is at 0, 5. And remember that these are symmetric, right? I already knew the axis of symmetry, and the other point was right over here, right? If they're going to be symmetric, then the y values have to be the same. That's where I get this y value of 5 right there. It's because the y value of 5 given to me in the point has to match the y value in that second point. All right, let's do another one. We're only going to do it in math form. The vertex is at 0.59. A 0 is at -2.5, 0. So I know my axis of symmetry is going to be x equals 0.5. And I know the point I'm working with is at -2.5, 0. So take 0.5 minus the other point, -2.5. Well, 2 negatives make a positive, so that becomes 3. Take that sum, 3, and add it to the AOS, 0.5, which gives me 3.5. So my new point is going to be at 3.5, 0. And the 0 comes from the fact that the y value of the point I used was 0. So that y value has to match at 0. Okay, let's do one more of those. The vertex is at -2, -8. So I know my axis of symmetry is going to be x equals -2. And a point on the parabola is at -1, -7. Okay. Take my AOS and subtract the point, the x value of the point from my AOS. So -2 minus -1, Two negatives make a positive. So this becomes -1. Add that -1 plus the -2, right? I got to add them together, right? That's what it says. Now they're both negatives. Well, that makes it really nice and easy because I can add two negatives, right? That becomes -3. So my point on the graph is going to be at -3. And what do you think the y value is going to be? Well, if you said -7 in your head, you're absolutely correct, because it has to match the y value from the point we're using, because this is a symmetric point across from it. Okay? Now, last but not least, it says describe how to determine another point on a parabola if you're given one point and the axis of symmetry. Well, we've done this now a couple of times, but the first step, subtract the x value of the point from the AOS. And step 2, take that sum and add it to AOS. And there you go. All right, hopefully you enjoyed this lesson. Short and sweet. We'll see you the following week. Well, you got one more video coming from me this week. So other than that, have a great week. Remember office hours from noon to 1. If you have to have a login, you have to be logged into Zoom, and make sure you use the password. It is located on the front page of Canvas. All right, bye-bye.